This is a brief video on demand estimation using Excel functions, and I think we did some some interpretation exercise in the last part of the last lecture of demand equations, and I showed you some example data and some graphs on demand equations. Now let's create one ourselves using the data collected over time here. This is a time series data. As you can see, it is collected over time, over several years. These are monthly data, sales data. So the date is just the date column. The sales is the quantity demanded column. So this is a number of, let's say, pies sold during this month. 193,334 pies sold during that month at the price of £6.39 per pie, let's say. And this is the amount of advertising spending of a company that produces this pies and sales. And this is the price of substitute pie produced by competitor, and this is the average income in the region, let's say, in again pounds, and the population is 4 million people, and this is a time trend. We ignore it for the time being. Now the objective is to estimate demand equation where the sales will represent the quantity demanded, and others will so these variables will then determine the quantity demanded. And as we discussed, one of the factors that determine the demand is the price and main factor, and how spread the knowledge about the product in the region, which is determined by the spending on advertising and other factors that affect the demand of the producer's pie is basically competitor's price. If competitor's price is higher, usually people substitute or switch to the company's pie. So here is an example. So in March, producer had a little higher price. In June, the competitor had higher price. In June, the competitor reduced the price to £4.84 per pie, while the producer, this producer that we're looking at, has actually increased their prices. And as you can see, demand for their pie declined from 193 to 170 pies, and as they reduce the price, again the demand increased. So let's have a look at it in a graph, which gives us better idea. So we go and leave our cursor out there somewhere away from the table, so that the table, graphing facility or functionality doesn't capture all the information. So leave the cursor outside the table here. So then insert, and we usually do scatter graph if you want to look at the relationship between two variables, in this case sales and the price. So right click, select data, and now we do this add. So now we would like to have pie demand analysis as a title. You can put anything that's relevant to this exercise. In the x-axis, which will be our horizontal line here, we will have the factor that affects the demand, and main factor is the price. So let's highlight this price factor. So all the data here highlighted, and in the y-axis we will delete everything and highlight sales here, right? And OK, and now press OK. We will have this sort of function. This is interesting. We've got huge unused area which we will need to remove. So we'll right click, format axis, and then we say bounds start from maybe 4.8, 4.8, yeah, to 8. Okay, yeah, that is better. Now I could see the relationship is negative, which means as the remember, this is the price, this is consumption, which is the demand. So let me put the labels first. Design quick layout. So we put, which one is better? Pie demand. So let's put the axis titles here. So this is price in pounds, and this is sales. Now this is the volume. I guess this was volume, I do not remember. Let's leave it as this. Usually this is sales is usually the volume, but I should check the specifications. In the next video we will discuss. No worries for now, it won't affect our decision here or the way we are analyzing this this data. Right, so I can see that as we increase the price, the demand basically declines. The way we look at it is by fitting a straight line on this data that describes the data's behavior. So let's right click on the data and add trend line, and here we can choose linear, exponential, or polynomial, or power. We usually do linear because we're looking at linear analysis for now. And let's display the equation on chart and display the r squared on chart. So let's close this now. Now here it is. This is our demand equation, and this is our demand basically line. So we may need to change it to a better shape. Okay, let's choose something solid. Yeah, this is better. And something something thicker. Yeah, that is better. Now what is this? This is basically the equation. We could think of this as a demand equation. Let's write this down here. So y-axis was sales, and this is negative this number times x-axis, and x-axis, if you remember, was price, plus some sort of value here, and r squared. So basically what this relationship tells us is this: if the pie price, the price of the pie, increases by £1, the demand for pie declines by this much, this negative value here. So 87,282. So this is the quantity. So if the pie price goes up by £1, so just plug in our pound here, 1 times this gives us negative this number. So the sales volume will decline by this much. If the pie price is 0, so this is just giving away the pies basically, this would be the demand value. You see, this is a huge jump, 930. So obviously if it's a free pie, then everyone would take it. So that's why you get a huge value here, large value. So this is the intercept, basically describes when the price is 0 what the demand is. But when you increase the price by £1, the demand for pie will decline by this much. So this is basically an example of demand curve estimation. Now in the next video we will look at forecasting and interpretation using multiple variables. Instead of one price factor affecting the demand, we'll look at the price, advertising, competitors' price jointly affecting the demand in the next video. Now for now, let's look at the r squared. This basically tells us, this value tells us how well this line describes the data. As you can see, some of the points here, let's say this point here, is just telling us a point where price is £7.04 while the demand is 634,934. So this is the point there, and it is basically the actual point being described at this point right on the graph here, described by this line. So there's a huge error here. So these errors, if they are basically, if these errors are huge, then r squared will be low. If the dots are clustered around very close to this line, the r squared will be very high, up to 1. So r squared basically will have a value between 0 and 1. A value close to 1 gives us tells us that the demand equation is more accurate. But in this case it's a less accurate demand equation because it doesn't really describe many of the points lying up there and below here. So it's not bad, but for exercise and for learning. But in the next well, when you interpret demand equations, you have to look at r squared carefully, and if it's a high r squared, then you can go ahead and rely on the data, on the results. But in this case, data or the results, these results are less reliable, less accurate, in other words. Okay, so that is the fit, what you call this, coefficient of determination or goodness of fit value here. This needs to be as high as possible. Close to 1 is more favorable. Okay, see you in the next video.